Let's now see what is electroplating. Now, electroplating, the use of chemical reaction of electric current is known as electroplating. This is a procedure where a layer of metal is built on other metal, like the iron handle of a cycle has a layer of nickel. Silver ornaments have a layer of gold. The metal or item on which the layer is supposed to be made is added with positive terminal, and the metal which is used for thin layer solution is added with the electrode to produce electric current. Okay. Now what happens is that, see, this is copper sulfate solution. Look at the diagram. Look at the diagram. This is copper sulfate solution. This is an iron nail. And this is an electrode. Okay. Okay, this is an electrode. The electrode is having positive terminal. Okay, the electrode is having positive terminal, whereas the head of the nail is having negative terminal. Okay, both of these terminals, the positive terminal of the electrode and the negative terminal of the nail, okay, they are connected together with a battery. Okay, look in the diagram, Emma. Look at the diagram. They are connected with a battery. Okay, so the electric current passes from the positive terminal of electrode, like here, and goes to the negative terminal of the iron nail. Okay, and that creates a coating. Okay, that creates a coating of metal on the nail, on the iron nail. Okay, this is the process of electroplating. This is the process of electroplating. Okay, I will show you a video on electroplating.
Hey, ma'am, sorry I'm late. My internet connection was not working.
Okay, Braham, it's okay. I just started with the topic of electroplating. I explained electroplating, and now we are seeing the video on it. Now we're seeing the video on it, how it works. starting on one end. First, they mixed copper sulfate solution in the water, okay, to make a copper sulfate powder in the water to make it copper sulfate solution. Okay. Once copper sulfate solution was made, they used this wire, this twisted wire-like thing in the form of electrode. Okay, in the form of metal in the form of electrode. Connected it with a battery on one end. Okay, and then on the other end we put the thing that we want to electroplate. Okay, like a spoon and a coin. Okay, so this current passes from the electrode. Okay, this current passes from the electrode towards the thing that we are electroplating. Okay, and it forms a layer of copper. It forms a layer of copper on that thing. Okay, so this process is known as electroplating. Now, okay, also please remember that the metal or item on which layer is supposed to be made is added with the negative terminal of the battery, and the metal which is used for thin layer solution is added with electrode to produce electric current. Okay, the electrode that we are using, the electrode metal, that is attached with the positive terminal, and the thing that we are going to electroplate, that thing is attached with the negative terminal, because from the electrode the current will pass, okay, towards the thing which is going to be electroplated, and then it will be like this thin layer of copper will set on that item, okay, when the current passes through it in the copper sulfate solution. Okay, that is the process of electroplating. Understood now? Understood. Let's do in-text questions 14.5. How will you make magnet out of an iron nail?
Ma'am, you would rub a magnet to an iron nail, so pieces of the magnet start to break off and stick to the iron nail. Thus, you have made a magnetized piece of iron.
Mm-hmm. Yes, it is. Write any two names of electric magnets used in our homes. Or devices that use magnets in our home.
Ma'am, laptop, phone, and speaker.
Okay, yes, laptops, phones, and speakers, they all use magnets inside them. Then, what are the uses of electric current in electroplating?
Um, the use of the electric current in electroplating is so that from the copper from the solution will go into the cathode.
Yes, right, Abraham. What is the name of the electrode joining the positive terminal?
Um, ac- Antidote.
Did you say?
And one moment.
Okay, I think it's cathode and anode only. Okay, the this one. Okay, the electrode, the metallic electrode, is known as cathode, and this one is known as anode. Okay, so it is cathode and it is cathode, which is the positive terminal. Okay, where the electrode has joined the positive terminal, it is cathode, and the other one where the oxidation is occurring or where the plating is taking place is your anode. Okay, which two gas molecules are formed by breaking of water molecules?
Hydrogen and oxygen.
Hydrogen and oxygen. Yes. Terminal exercises. Choose the correct option. Magnet attracts
Iron powder.
iron powder. Non-magnetic items are
Iron and nickel.
iron and nickel. Non-magnetic.
Sorry, ma'am. Then gold and cobalt.
Then copper. Take the correct statement and cross the wrong one. Magnet is not used to check the utensils of stainless steel.
False.
Magnetic powder is on the center of magnets.
False.
There is attraction in the same poles of magnets.
False. Ma'am, what is magnetic powder in the center of the magnet?
Magnetic powder in the center of the magnet. It is, I think it refers to like the powder that is found inside the magnet or in the center of the magnet. One second, let me just check this out. Okay. Mm, Abraham, magnetic powder is like the powder of iron or something. Okay, the
Mom, I
powder
just
of
figured it out.
iron.
I have a small bottle of it. It's like iron dust, like dust which they make.
Mm-hmm. Yes, yes. So
I think it goes by the name
this iron dust,
iron.
this iron dust, when we take a
Ma'am,
magnet around it, it will accumulate or it will attract. It will be attracted towards the poles. Okay, towards the north pole or south pole, not in the center.
and ma'am,
Okay.
uh, it forms the magnet field line
Yes.
on a piece of paper. And ma'am, I
Yes.
think it goes by the name iron filling.
Say again, Abraham.
I think this iron dust it goes by the name iron filling.
Iron filling. Yes, Abraham, iron filling. It goes by the name iron filling. That is right. Okay. Now, there is attraction in same poles of the magnet. True or false?
Then that is definitely false.
False. Yes. Copper is a good conductor of electricity.
True, copper is because it's a metal.
Yes, true. Now, we will take a look at some question and answers. What is an electric magnet and how it is used?
Electric magnet is a magnet made when electricity starts flowing through the magnet. These magnets become very powerful. These can be used to segregate metal from non-metal. Example, uh, electric magnets are used to segregate to scrap cars. They are very efficient as they can be turned off and on in order to release and pick up the car.
Mm-hmm. Okay, yes, Abraham. Electric magnet are also called electromagnet, and in them the magnetic field is produced by electric current. Okay? When the electric current passes through them, it produces electric current. Sorry, it like produces a magnetic field. It forms a magnetic field. Okay, when the electric current passes through it. Did we have the diagram of this thing? This is actually the diagram of electric magnet. Electric magnet or electromagnet. Okay.
Yes, ma'am.
How does a needle convert to magnet? We studied this, right? I don't think we did. Hmm. Okay. We are like left with some portion to do. First, let's complete that portion. Heating effect of electric current. When electric current passes through carrier or joining wire, it gets heated up. Therefore, heat is generated in electric current. Yes,
Ma'am, did
Abraham?
you know that we have magnets more powerful than Earth's magnetic than Earth itself?
I heard about that. Hmm. Now, the heating effect of electric current. Okay. When the electric current passes or when electric current takes place, it also produces heat. Okay. It also electricity also produces heat. Therefore, if you touch any light bulb, you will feel its heat. Electric current flows in iron, making it heated. Okay. When it flows in iron, our iron, it makes it heated. Okay. The iron is like the device we use to iron our clothes. Okay. When we connect it to electricity, when we connect it to the switch and turn it on, electric current flows in it. Okay. in a way that it makes it heated up. In that heat, we used to iron our clothes. Okay, when bulbs also light up, if they are like after some time when we touch them, we'll feel them they are hot because electricity or electric current produces heat. Electric current characteristics are also found in geyser or rod to heat up the water or in heater to prepare food. Other things which use this property, which property heating effect of electric current are geysers, okay, rods to heat up the water, and heaters. Okay, heater also we plug it in. Okay, electricity passes through it, and the rod in the heater lights up and produces heat. Also in geyser, the current or electricity passes in it. Okay, it gets heated up, and then it is connected with our pipes, water pipes, and then it heats up our water. Okay, so um, the effect of carriers get heated up by electric current is known as heating effect. This effect is known as heating effect. This effect is found in different objects and in different quantity. Yes, Abraham? This effect is found in different objects in different quantity. Heating effect is dependent on the length and the thickness of carriers. Okay, the length and the thickness of the wires that are attached with the in the circuit. Okay, long and thin wire gets heated more, whereas small and thick wire gets heated less. If you have long and thin wire, they'll get heated more. If you have small and thick wire, it gets less heat. Okay, now how does a bulb light up? This is how a bulb works. A spiral of thin wire is prepared by tungsten material inside the bulb. Under this bulb is made to wind up wire in a small place. Tungsten is a thin wire and it gets more heated. However, tungsten does not melt easily. Therefore, it is proper material for the bulb. When it gets heated with electric current, it starts shining. Okay, this is the light emitting of bulb. Electric bulb gets heated in large quantity to emit light in bulb. This energy next is extra and waste to us. Therefore, tube light, CFL or LED bulbs are used in place of big bulbs. They work on less electric supply and they save energy. Now inside the bulb, okay, inside the bulb, you have this tungsten wire, which is very thin, okay, which is a thin wire. And when the electricity passes through, okay, the bulb is connected with the circuit on this side, connected with the circuit on this side. When the electricity passes through it, it heats up the tungsten wire and it emits this light, okay, and it gets lighter. Okay, the bulb lights up, but this takes a lot of electricity. This consumes a lot of electricity. So instead of using these big bulbs for emitting more light, which are using more energy, we use CFL or LED bulbs, which use less electricity. Okay. which use less electricity. Now, because they save energy. Okay, understood? Understood till here? We are using the effects of electric current. Okay, basically there are three: heating effect of electric current, okay, magnetic effect of electric current, and chemical effect of electric current. The question comes, what are the effects of electric current? Okay, these are the three major categories that you have to explain: the heating effect of electric current, magnetic effect of electric current, and the um, chemical effect of electric current. Okay, now what is fuse and what is its use? Let's take a look at that. A weak link is made in a home to supply electric current. This melts the wire in small amount of heat. The circuit breaks down. This is known as fuse. Short circuits happen when more electric supply is passed accidentally. This may lead to fire. To stop this danger, fuse is used. Okay, it is a small inner like circuit box. It is a small lever-like thing. It is a small lever-like thing. Okay, if um the electricity comes in very high voltage suddenly, okay, this fuse drops, okay, means it cuts down the supply, okay, it breaks the circuit, okay, it breaks the circuit and cuts down the supply of electricity in our home, so that the electrical appliances, if they get too much of electricity at once, it will not break. Okay, many of our electrical appliances take a lot of load. Okay, and short circuit may happen, like refrigerator, like air conditioner, ACs, and all. Okay, if a lot of electricity supplied all at once, then they may take a load. Okay, they may break down. So to stop that, to stop this huge massive electricity, it breaks the circuit. Okay, the fuse breaks the circuit and it stops the supply of electricity. Then later we can go and put up the lever. Okay, and that will connect it again. That will connect it to the circuit again, and we'll get the supply of electricity. Okay, this is the weak link. This is known as the weak link in our homes to supply electric current. Okay, so the symbols are there. Okay, the symbols are there. We saw the symbols yesterday. Please learn how to make electric cell, electric bulb, carrier wire, battery, switch on and switch off symbols. Okay. Write any three names of good and bad conductors of electricity.
Those conductors of electricity include metals, iron, copper. Bad conductors of electricity include plastics, wood, and glass.
Yes, Abraham. Correct. Good. Why does a lighted bulb heat up? Heats up. Why does a lighted bulb heat up?
A lighted bulb heats up because of the light energy that strikes the bulb.
Yes, because the wire present in it gets heated up when electricity passes through it, and it leads to the production of energy, which causes the bulb to light up. Correct.
Ma'am,
Okay. Yes.
and did you know in a bulb that uses tungsten to light up another old-fashioned bulb?
Say again, say loudly.
Ma'am, do you know the old-fashioned bulb, the one that uses tungsten?
Mm-hmm. Yes.
Ma'am, over there, because of the bulb and the electrons flowing, sometimes the electrons will fall on one side of the bulb and make it discolored.
Make it discolor.
Yeah, the glass side of the bulb. If this is the
Mhm.
bulb, the electrons are coming like this. Sometimes they will fall on this side and make it discolored.
Oh, okay. Mm, okay. Yeah. Write any two instruments used for electric current heating.
Mm.
You have to write, I think you have to mention that any two items that use the heating effect of electric current.
Um, Ma'am, I don't think I know.
We studied a lot of them, such as heater, geyser, iron, heating rod. Okay.
Ma'am, basically the ones that use
Mm,
electricity in them.
yes.
Ma'am, I could say
The ones.
laptop and so and so.
Okay. But laptop also gets heated up when we use it for a long time. Okay. But that is like can be an example, but not really. More accurately, examples are this heater and all. Okay, heater, iron, geyser. Okay, these are like they actually function. Their actual function is to produce heat and provide us utility with the help of electric current. Okay, that is why. Now,
Ma'am,
tomorrow, yes,
and did you know when a battery gets too hot and it starts a fire, it has everything in it to continue the fire. So
yes,
it's
it does.
almost impossible to stop.
Yes, that is true. That's true. Now, magnetic effect of electric current we will do tomorrow in more detail. Okay, and the remaining terminal questions we will do. Chemical effect we studied. We will read this. Okay, we'll check out this and we'll do the
Okay, ma'am.
remaining terminal exercises. Today you have test. Okay, today you have maths test. So I'll send you all the maths test in a bit. Okay, I'll send all the maths test in a bit. Please do.
Okay, ma'am.
Can you all submit it to me by today itself?
Yes, ma'am. I'll try to like finish it by today.
Okay. Then submit it to me by today. Today itself do the test and submit it to me. Okay. And I'll meet y'all tomorrow. Okay. See y'all then. Bye.
Bye, ma'am. Thank you, ma'am.